that we've seen what the parent functions look like and some of their special features, what we're going to do now with them is we're going to start transforming them. So we're going to be moving them all over the place. So in general, if y equals f at x, then if I want to vertically displace something, this is what would happen to the equation. I would have the normal equation, my parent function, and I would add or subtract something. So that's a vertical displacement. It means I'm going to be moving the whole function either up or down. Now, I'm going to click on this link here. Now, on your blank sheet, you do not have this link, but if you want to actually play around with it yourself, feel free to pause the video and copy down the link, and that way you can actually see how it moves the graph, the parent functions around. All right, so vertical displacement. So what's nice about this particular website is it has the majority of the special parent functions that we're responsible for this year. So, so you can see it has the different graphs. Okay, so let's take a look at something we do know. We do know things about a straight line. So what happens if I add something, this plus k, so here's our f at x. I'm not too concerned about the minus h right at this moment, but plus a k. So if I take the normal equation of y equals x, and you can see that there, and actually maybe what I could do is, if I was thinking I could maybe expand it, and just hold on a sec, I'll see if I can. All right, so it's a little bit larger for you to see, but you can see I have y equals x. So when I add something to that function, such as a positive 2, notice what happens. Here's the normal function y equals x, but when I add 2 to that function, the equation then becomes x plus 2, and you can see it moves the graph up. The same is true if I take it down to negative 2, it moves the graph down. Okay, so it keeps moving it around. So it's still a straight line. What has changed this time, however, is I've taken that whole function, moved it down, and it's changed, in the case of a line, it's changed the y-intercept. Now the same is true if I take one of these other ones. Okay, you've worked a lot with parabolas before, so same kind of thing. Here is our parent, y equals x squared. If I add something to it, the parabola, it keeps the same shape, but it moves up. If I subtract something, it moves down. So no problem there. And let's take a look at this absolute value graph. Same aspect. There is the graph. If I move it up, I just add something such as plus 4.3, and it moves the graph up. Negative 4.3 moves it down. So what you can do is you can play around with those if you so wish. Now, the other kind of translation we're looking at is if I open up my function and I throw something in with the x. So what happens there, we call this a horizontal displacement. So in other words, we're moving left or right. That should be or right and or down. And remember that we always move in the opposite direction of this sign that they show us. So if it says a negative 3, we're going to move it in the positive 3 direction. If it says positive 3, in the positive direction. So again, just like the last example, I can go to this function again, and we can take, this time we'll take the parabola that's on its side, okay, the square root function. And if I put a positive number in there, so it becomes like negative 1.95, you can see what's happening to the vertex 0, 0. It's moving it to the right. And if I want to move it to the left, notice the equation is x plus 4.5, so it moves it in the opposite direction of positive to the negative direction. So both of these translations deal with things that we've done with parabolas in the past, especially grade 10 and also last unit. So now let's take a look at how do I graph these things. So steps for graphing. These, for the most part, work pretty well. Okay, so the first step is determine the parent function that you're dealing with. Sketch the parent's function's important points. Okay, that's what I'm talking about for important points there is I'm referring to the step pattern that we talked about. So it's the step pattern that we're interested in, and I'll just put step pattern so that you know that that's really the important part there. So the step pattern is what we're interested in, and if there's a vertex, that becomes part of the important points also of the parent. All right, then what we do is we apply the transformations to those important points, and also it will affect any asymptotes. Okay, so if I'm moving stuff around, it's going to affect where the asymptotes are located, and remember I need to mark them with dotted lines. So the asymptotes on these graphs has to be shown, otherwise you haven't graphed it correctly. Okay, and then always make sure that you label your axis both with numbers and with X and Y. So let's look at the first example. Okay, so the first example says f at x equals the absolute value of x minus 2. Okay, so step number one says, what is my parent function? Well, I know that parent function is the absolute value graph. Okay, and I know it has a vertex at 0, 0, and I go over 1, up 1, over 2, up 2. Okay, so I know that. Now, because I'm only doing one translation, I'm not going to draw the parent graph on here. I have this on the side just to help me with that. So what I'm going to do now is I am going to go and draw my little points. So what happens here is normally it would be at 0, 0. But because the x value has been changed, and remember it's in the opposite direction, it means my new important vertex is at 2, 0. And then I follow my step pattern. So over 1, up 1, over 2, up 2. So you can see, and we know that this is symmetrical about that vertex. And so we have enough points here, and all we need to do now is to actually draw our line through those points. And also we should add arrows because it does go on forever. We're only seeing a portion of this function. Now it also asks us to state the domain and range. So let's take a look at the domain and range of this translation. Okay, so when I look at this translation and I look at, first of all, the x values, you can see here's the x axis, and there is a little x there if you can't see my labeling. And you can see that x can be -5, it can be +5, so it appears that x can be any real number. So that's the first thing we're going to write down. So x is in the set of, sorry, that looks kind of crappy, set of real numbers. And we also know our range is going to be in the set of real numbers, but let's take a closer look at it to see whether we have any restrictions on it. Well, we do have restrictions in this case. In this case, we have, you can see that the y, I'm never going to get down into the negative values. So it appears that I'm going to be 0 and higher. So we're going to put that x, sorry, that y, element of real numbers, such that y must be greater than or equal to 0. And obviously we want to put this in the fancy parentheses. All right, so that's the first graph. Really not too bad. Okay, let's look at the next ones. Okay, the next one, and I'll just bring up the shade. There we go. Again, it's the square root of x minus 3. So what is the parent function? Well, the parent function I know is starts at 0, 0. It goes over 1, up 1, over 4, up 2. Okay, so what's happened here is the x is still in the correct spot. However, you can see that they're taking this whole graph and they're moving it down 3. So we're moving it down 3. Sorry, so normally it is at 0, 0, so down 3 it's here, and then I'm following my step pattern again. So over 1, up 1, over 4, up 2. It's that simple, and then it's just a matter of, again, drawing our smooth curve through there, and we'll see how smooth I can make mine. And obviously put arrows again. So our domain this time, again, is x is in the set of real numbers, but let's take a closer look at it. You can see that in this question, x can never be anything in the negative zone. Okay, so it's got to be 0 or higher. And also, if we look at the range, we can see that it stops here at -3 and never goes below that. So that tells us what our domain and range are. So x here has to be greater than or equal to 0. And our range is y, also an element of real numbers, and it must be greater than or equal to -3. And finally, our last question here. Okay, so we have this one, y over x plus 3 plus 4. So they have a couple things going on here. But first I need to recognize what my parent function is. Now this time I didn't draw it, so I know I have my axes. And I also know that this is a graph that has those asymptote lines. So on the parent function it has the asymptotes. And remember, from the asymptotes, I go from where they intersect and I go over one, up one, and I go to the left one, down one. Okay, so I know those are my important values, and then my graph kind of creeps along that. So I need to know that information, because what's going on here is my x is going to move uh, left 3 left, and my y is going to move up 4. Now, first thing I'm going to do on ones that have asymptotes is I literally am going to draw the asymptotes in. So if I'm looking at moving up 3, it means that if I take this middle asymptote line, if I move it up 3, you can still see that it stays in the same direction. So it really doesn't change. The one that it does change sorry, as soon as I get it, is this one. So it moves up 3, sorry, up 4. So it doesn't matter, it moves up 4 no matter what. Okay, so I know that this one no longer is along the x-axis, but it's actually crosses the y-axis at 4. I also know then left 3, it means that which one does it affect? Well, if I'm moving this one, obviously, which I don't want to move, if I move this one left 3 or right 3, it doesn't affect anything because it still stays there. However, it does make a huge difference on this one. If I move it left 3, you can see that it actually moves that asymptote line. So that's the second one that I'm going to do. So normally it's here. So 1, 2, 3, and there is our 2 asymptote lines. And now the same kind of step pattern we had before. We know that where they intersect is where I put my point. So over 1, up 1, and to the left 1, down 1. Okay, so I have my 2 important points, and now it's just a matter of letting that graph creep and go through there, and it continues, gets closer to those asymptote lines but never touches them. Okay, so that's what that equation looks like graphed, and now it's just a matter of doing our domain and range. Okay, so if we can see that, first of all, that x can be anything in here except at asymptote. And the same thing is for y. Y can be anything except at this asymptote line. So let's write that down now. So we have x is in the set of or an element of real numbers such that x cannot equal -3. And we have y is an element of real numbers, and y cannot equal +4. Okay, you can do some tomorrow in class.